Welcome back, everyone, to a new session here. Thank you, everyone, for joining us. A big welcome to our new members here. If this is your first time, we're very happy to have you. And if you're a returning one, welcome back again. We're also happy to have you. A little bit of introduction about who we are in case you're new. We are Pre-Health Shadowing. We are an international-led student program, also women-led, minority-led, and nonprofit for medical advancement. And what we do is we focus on bringing a lot of professionals from the entire scope of pre-health for you guys to shout on, ask your questions, and get a lot of insights as you can. We do love to accommodate for everybody's needs and questions, so we do have closed captions throughout our live sessions. If you have more ideas or more stuff that you want us to have more accessible for you guys or to accommodate, you can always email us at info@prehealthshadowing, and we're very happy to take anything that you have in concern. It's great to keep with us in the loop since we have a lot of stuff and a lot of programs and a lot of events coming up for you guys. You can always stay in the loop with us to sign up for our emailing list. It's a very easy form you can fill out on our website. We will also have it in the group in the chat for you. So you can join our mailing list to get all the reminders and updates on everything that we do, upcoming live sessions that we have. We do have a lot of upcoming interesting live sessions that we have scheduled for you guys. You can also follow us on social media platforms like Instagram, TikTok, LinkedIn as well. And we do share the same handle, which is at Pre-Health Shadowing. One thing that I truly love about PHS live sessions is that all of us join from all around the world. Sometimes we see students that are joining from all the way across overseas. So please go ahead in the chat. Let us know where you are logged in from today. You can put your answers in the chat. If you are looking up to stay more interacted with PHS rather than just joining, which is, of course, is a very awesome thing that you can choose to do, but you can also join us as a student volunteer or also as a team member on our board. For a student volunteer, each role has its own requirements, time commitment, and all of that. For sure, as a student volunteer is a little bit more or less than a team member, but all of the work that we guys put in, we appreciate. There are two very easy forms that you can fill out on the website. You can just put your name, your info about yourself, where are you really currently, if you're in high school and college, what you look up to do, and why do you want to join us. And you can find all of other information about each role also on the website. We are recording, and so one thing that I love about these roles are they're very flexible and it's fully online remotely. You don't really have to go anywhere or join in anywhere, and the environment of our board is very awesome and kind and very flexible. So again, you can always join us from wherever you are. Within the leadership of PHS, we don't just have the live sessions, but we do have different departments, and so you can always take in the role of each one of them or different ones. As a volunteer, you choose whichever you want to go through and volunteer through. As a team member, you are specified a certain role within a different department or a different program that you take in. But example departments we have like the IT, we have the research program where you are matched with another research mentee to get to know all about research and leadership within it. And also we have our HR, we have the live session as well. You can always choose to join. All of that we have on our website, so you can always choose whatever you feel like it's the best for you and join. We do also have an HTP program, which is our high school training program. It's offered for the high school students that are currently have a chapter. Even if you're not, you can also open one. But what it is, it works with high school students to enhance healthcare educations for them wherever they're starting off for their pre-health journey. So it's a very easy, quick form. You can join us if you're in high school. You could fill out the form with your information and we can get back to you. Since this program, it's a nonprofit and free for all of you guys, so we do our built on donations. So any donations that you can get us, if you know $1 makes a difference. It's very helpful to keep have this program accessible for everybody and free. So if you can scan the QR code and donate whatever you can, or share it as well with people, friends, family that you know that they can donate, we will truly appreciate it. Throughout this amazing live session with our professor here today, I'm sure we're going to learn a lot. So you can always type your questions in the chat. We will have a Q&A at the end of the sessions where you guys are open to them, and you can have all of your questions and insights answered. Throughout the sessions, you're very free and welcome to take any notes that you would like. You will have a shadowing quiz at the end that will be available on the website after the live session is ending. It's a very easy 10 questions that you will be able to take and gain hours for your shadowing today. So feel free to take any notes that you want to jot down, and I'm sure we'll learn a lot today from the amazing professional. So you can take it and keep it for later if you also would like to. Since we are remote, and one of the way to keep us all engaged and all together is to have our cameras on. So if you are able to have your cameras on today, please go ahead and do so. That will keep us more interactive and engaged as we are remotely today. That's it for me on my end. I'm gonna go ahead and share it to our amazing professional. You can go ahead and share your screen and start your presentation. Thank you for being here with us today.
Thank you. Thanks for the invitation, and for everybody to join. Appreciate it. So, according to the instructions from the pre-shadowing group, I have about 30 slides to show on the topic of a topic that you know quite a bit already about, which is sleep and about sleep deprivation. Currently, where I am, and I'll mention that. I give a course on sleep. It's actually to undergraduate seniors, which is a semester. So out of that course, I've got 30 slides, or about at most 45 minutes. So kind of an introduction to an introduction. And then in the remaining time, happy to field any questions on the topic, but also anything you want to ask me. I can always refuse to answer. But you can ask anything about any topic. So let me share the screen, and let me make these. There we go. Okay. I'll just get a pointer, which I think I may be able to use later. So my name is Bill Schwartz. Wait. Here, I'm still messing with this. I'll get rid of that. Okay. I wonder if I can put this up someplace. Okay. So I'm a neurologist, and I'm a professor of neurology at the medical school, recently started at the University of Texas at Austin. And previously, and we can talk about it if you'd like to hear more about where I've come from, was really from both coasts. I'm also currently a visiting professor at a university in the Netherlands, University of Groningen. So today's topic will be on a bit about sleep and on sleep deprivation. And this is something that I'm sure everyone has some experience with, so we'll be able to share your experiences as well. And the first order of business would be, what are the consequences of not sleeping enough? And we'll define not sleeping enough a bit later, but what kind of consequences are there? And I have a couple of slides on those. So one of them, and this is starting to look like, I don't know, in high school or college, whether people are showing these kinds of gruesome slides anymore. But one of the consequences is death, actually. Especially, as you'll recognize here, I see some of you are from Texas or the Southwest. You'll encounter roads like this where it's quite easy, if you're deprived, to fall asleep while driving. And a couple of points here is this graph down here at the bottom left relates to the percentage of individuals who fell asleep while driving in a preceding month, broken down by the usual sleep duration of less than 6 hours a night or 7 to 9 hours a night, whether they snore or not. But we can just look at the dark bars, and you can see with sleep deprivation or inadequate sleep, the chances of falling asleep while driving, double here or something like this. This graph over here on the right is really a scary one, which is what is the outcome for someone who's a drowsy driver? What's the likely outcome if they get into a collision, if they get into an accident? And you can see the most common outcome is death, a fatal outcome. Death, it's in all crashes combined with all sorts of things. Perhaps 6% result in death, 20% with the drowsy driver. Here are the percentages with severe injury, any injury, no injury. And you could probably guess why the fatality rate is so high, is that if you're nodding off or actually sleeping, you're not in a position to even recognize what's about to happen or to make corrective action. So one of the consequences of sleep deprivation is death. Here are some stories. Here's one relatively famous story about an airline. It's a Hawaiian airline, Mesa Airlines. I don't know if it's still running, but this was an event in 2008. Mesa Airlines, flying from Honolulu to Hilo, departed in 2008 at 9:15. At 9:40, there was no response from the flight crew to the air traffic controller. 9:55, the airplane flew over the Hilo airport, overflew it. And if you know anything about the Hawaiian Islands or the geography, you'll realize that flying from Honolulu to Hilo, you're flying more or less east. And if you overfly Hilo, the next land is the coast of South America, and you're not going to make it in this plane. Finally, 3 minutes later, ATC was able to contact the pilots. They were then 26 nautical miles past the airport. Turned out that both pilots had fallen asleep after they had engaged the automatic pilot. The date of this flight was the third day in which this team had awakened at 4 a.m. to start their flight at 5:40. The captain was later diagnosed with obstructive sleep apnea. Here's a quote from a professor at an aeronautical university in Florida. In the military, pilots flying alone have been allowed for decades to take naps. I can tell you absolutely, but good luck trying to find proof. In the military, we have single-seat pilots take naps. They call them ORPs, officer rest periods, and last from 10 to 20 minutes. Well, what are some of the other consequences? Well, one that you'll appreciate is neurocognitive. There are broad cognitive performance deficits. Your brain is not operating as well. I'm sure everyone has this experience. And here, without memorizing them, is sort of a list of some of the kind of performance deficits. And what they have in common is they're relatively sort of more advanced. So instability of attention, slowing of cognition, for example, and especially when time pressure starts to increase them, just the response time starts to slow, memory. Here's performance requiring divergent thinking deteriorates. That is, thinking about what if, or thinking the opposite of what you might imagine you're going to be doing. So more advanced things, suppressing errors, and so forth. There's just more effort to remain effective. Over here are just some data, and we're just going to look at it just broadly. So in these experiments, the individuals were sleep restricted for 2 weeks. And the different symbols represent how much sleep they were allowed. So there were different groups in this 2-week restriction. individuals could sleep for 8 hours, so that's hardly anything for most, 6 hours or 4 hours. And on the y-axis is an attention task, where the higher number is worse performance. And you may be able to see here the circles, which are the 4 hours with the greatest cumulative sleep deficit, have the worst performance. And, you know, it's almost linear in terms of related to how much restriction is. This is an experiment with 3 days of complete sleep deprivation. And you can see these are those cases there. So the question would be, you know, what's going on here? Why is the lack of sleep causing brain fog? Was that somebody asking a question?
No, sorry. You can continue.
Okay.
Sorry.
All right. So what are the possible possibilities here? And here I have 3 possibilities. One of them, which you'd think of immediately, is perhaps this represents the lost function of sleep. Perhaps sleep function has to do with keeping the brain, you know, up to par. And if you don't sleep, the brain is just not working as well. The other possibilities, and these are not mutually exclusive, is perhaps there's an increased drive to be putting you to sleep. That is, you're feeling sleepy. In the same way, for example, if you don't eat, you start feeling hungry, which sort of stimulates you to eat. But the function of eating is not to suppress hunger, right? So perhaps it's an increased drive for sleep, this sleepiness to try to put you to sleep. And that's what we're experiencing as brain failure. And the other is that actually, in fact, it is really very difficult to completely deprive yourself of sleep. We can talk about that later if you like. But what happens is microsleeps occur. And I'll bet that many of you have had the experience, perhaps if you're sleep deprived, driving on an interstate, if you're in the US, an interstate that you know well, and you're not getting into an accident, and you know, there are other cars on the road, but you suddenly become aware of the fact that you've missed your exit. And what we found is that sleep deprivation leads to microsleeps. These are micro, both in the sense of time and space. That is, they may just be moments long, that you know, you may not even notice as you're driving, say seconds, and or that they're occurring, and we'll define how they'd be occurring, or they're occurring actually in just parts of your cerebral cortex, the frontal cortex or the parietal cortex, while leaving the occipital cortex awake, in quotes, as you were. Here's the case with microsleeps, which with sleep deprivation is sometimes the cause of something called the automatic behavior syndrome. That is driving, but automatically driving. But, you know, if suddenly someone swerves into your lane, or if you find suddenly you've missed your exit, you realize that your driving was automatic. So in this experiment, time is on the x-axis. This is seconds. So from here, you'll see my marker from here to here is 10 seconds. And this is in a laboratory, and the subject is sleep deprived and is following a track on a computer screen, which is moving around. And he has a joystick and is supposed to mimic the movement, to follow the little dancing light. So the target is in the dark black line. This is the target going here, solid line. This is the target moving over time, okay? And then the dotted line, this other one is what the subject is doing, tracking. So they start out and you see they're following it here. These are superimposed, cool. They make this turn, they're going. Here, the tracking target you see is heading down and there's a lag. How long is this? Well, maybe a second and a half before the subject realizes they're off and makes this sudden movement. And then you can follow it similarly. Here, along here, over these seconds, they've missed this completely. That's a microsleep. They're really asleep. They sort of juggle here. Okay, now they're back up and they're following. Their response time here is slow. They're following pretty well. Here, again, they're down here. They've missed the target going up here. And so you can imagine with these repeated, these are showing sort of lapses of microsleep. You can see how if you were driving and there was suddenly something that required immediate attention, you might miss it. Here's another experiment of this type, which shows that, and that is, it's a measurement, it's a driving simulator, and on the y-axis is steering variation, sort of juggling the steering wheel. And, you know, someone who's driving pretty well has a minimum movement as they make corrections to steering. In these subjects grouped together, here's before when they're awake, here's during a microsleep episode, which is revealed, you know, in the laboratory by instrumentation, and here's afterwards. And here's the steering variation. Higher would be worse. If the road in the simulator is straight, so here the steering variation is pretty low. Here they have one of these blackouts, microsleep, and you see the variation is worse. Afterwards, it's better. If there's a curve in the road when the microsleep is occurring, here you can see the performance is much worse. And you can see how this might lead to the automobile against the tree that we saw in a previous slide. So cognition is impaired, and you may know stories about nuclear accidents or other kinds of industrial accidents that occur at night when people are on shift and maybe sleep deprived. But it doesn't end with that, right? So there are other consequences of sleep deprivation, which include immunologic consequences. And here is just a little cartoon showing a number from studies, without going through all the data, a number of things that are affected by the loss of sleep. And so these are all things that during sleep can occur that boost the immune system, which are impaired if sleep is deprived. Here's an actual experiment. This has to do with sleep duration in the common cold. And this is basically going to confirm that what your mother told you is actually correct. So this is 164 healthy volunteers. Sleep was assessed just in their natural environment for a week. And then the experiment began when a common cold virus was administered in the nose of the volunteers. And then what is measured here is the number, the percentage afterwards that actually developed symptoms of a cold, sneezing, coughing, sore throat, etc. And you can see the relationship between the percentage. Here's 50% is up here. So half of them don't develop a cold, even if you put the virus in your nose. But of the ones that do, you can see the relationship who develop colds based on their sleep duration. So less than 5 hours here, almost 50%, greater than 7 hours, what? Somewhere between 15 and 20%. So again, a clear relationship in terms of your immunologic capacity is handicapped with sleep deprivation. Here's one more that you may know something about as well, and that is metabolic problems. So you may have heard that people have described one consequence of short sleep or sleep deprivation is obesity and the metabolic syndrome, diabetes, hypertension, obesity, and all the health consequences of that. This is a study from the University of Colorado with 8 males and 8 females, about your age, I suspect. So young, healthy people. And the experimental subjects, there were 3 parts to the experiment. The first was a baseline where they had 3 nights where they were allowed 9 hours in bed at their usual sleep time. And then in a crossover design, that is, everybody had both shortened sleep to 5 hours or continued 9 hours. And half of them had the short sleep first and then the regular sleep, and the others had the opposite. And in all conditions, so everybody had both 9 or 5 hours of sleep. In all conditions, they could just ask for food when they wanted it or what they wanted to have. And the results are sort of shown here. I'll just show you a couple of these. One is the food intake. Here's the 5-day average food intake in the short sleepers was significantly higher than those who were sleeping longer in bed. So they were eating more. And not surprisingly, their weight increased. Also significantly down here, even though their energy expenditure, the ones who were eating more, expended more energy as well. And so what these investigators were interested in finding out was when were they eating? How many calories were they eating at different times? Because they could have it whenever they wanted. Here's breakfast, lunch, and dinner. And not much difference. Here are the daytime snacks. Look here, post-dinner snacks, right? That midnight pizza, when the liver is not expecting it. Here's where all the calories. So 42% more calories consumed as after-dinner snacks, more calories consumed at night after dinner than consumed after any other meal. And so you may know, some of you who are in college already, about the so-called freshman 15. And that's, the pizza and the sweets and so forth late at night, when your internal timing system is not set up. So part of the problem with short sleep deprivation, the metabolic consequences, at least part of it, may be what you're doing when you should be sleeping. So why are we all sacrificing sleep? Given all this, and given that you know all this probably, why are we sacrificing sleep instead of sacrificing wakefulness? Why do you say if you have too much to do, you stay up and pull an all-nighter or stay up instead of saying, no, I'm going to get my sleep and I'll just accomplish less? Why is that? Part of this, I think, comes from the Western tradition. Here's Sir Charles Sherrington, who won the 1932 Nobel Prize. And he had a series of famous lectures where he had gave an opinion on sleeps. And here's what he thinks: Nobel laureate, we choose the hour of deep sleep. Then here's what he imagines: only in some sparse and out-of-the-way places in the brain is anything happening. Are nodes flashing and light points running? Everything subsides. The great knotted headpiece, cerebrum, of the whole sleeping system lies dark, and quite especially so the roof brain. Everything is dark. It's turned off. The brain is turned off during sleep. And he was actually a religious man, and some of this comes in the Western tradition by those when we say, I fell asleep, or I'm falling asleep. I'm falling asleep, or I fell asleep. In the Christian Bible, King James Version, Genesis, God caused a deep sleep to fall upon Adam. Fall. So fall is a verb that means you're going down. You're going to a lower place. So that must influence sort of all of us grown up in a Western tradition, that sleep is a lower activity of lower value than wake. And whether you do it in Dutch, in German, or in Spanish, it's either passive or falling. Interestingly, and maybe some of you are familiar with some of these languages, and you can correct me if I'm wrong. But in these, which are not in the Western Christian tradition, it comes a little bit different. So in Hebrew, it's just I slept. Farsi is something like I'm taken away by my sleep. Hindi and others in our discussion, we can talk about it. Sleep came to me. Sleep carried me away. I was overcome by the sleep, right? So in other cultures, it's pretty clear that they don't feel that way about it. We can talk about it in the discussion as well, that sleep is not an inferior state of being. So sleep remains mysterious. And two things that we want to point out, which I'm sure most of you know, is that sleep is an actively generated state. It's not a passive lapse of function. So when you go to sleep, not fall asleep, in order for you to go to sleep, the brain, and we won't be able to cover all this from the neurophysiological point of view, but the brain systems responsible for wakefulness need to be turned off, and the brain systems responsible for sleep need to be turned on, right? So there's nothing passive about sleep. Everything about sleep, your immobility, the unconsciousness, the relative insensitivity to sensory stimuli, all of this is actively produced. And furthermore, sleep is a composite physiological state, as complex as a state of wakefulness. And because of that, it's given rise, the physiology, there may be disorders. And of course, that's why the specialty of sleep medicine was born. And with all that, here, a pair of famous sleep researchers, Tononi and Chiarelli, there is no other area of neuroscience, except maybe subconsciousness, that's so remarkably familiar and yet so difficult to define scientifically. So it remains a mystery. So let me make sure that we have a couple of basic sleep facts that we're all sort of together, because I'll use some of them. Again, we have limited time here, and many of you may know these. So sleep is divided into stages. This is defined by so-called polysomnography. That is with the electroencephalogram, brain waves, with electrodes to the scalp, measurement of eye movements, the electrooculogram, and measurement of muscle tension, the electromyogram. And from that, these are EEG, the electroencephalogram traces. You can see that the recordings look different in these different stages of sleep. And we won't go through sort of all of them, except to say that when you're awake, the landscape of the EEG, you'll see, is that the waves, these little jiggles, the waves are very fast, right? And the amplitude is low. This is sometimes called desynchronized sleep. And this is a desynchronized wake or drowsiness. And as you see, as you enter different stages until you arrive at a deeper level of sleep, what happens is the amplitude of the waves begins to get higher and the frequency becomes shorter. So here we're talking about random fast activity, here is very slow activity. You can make out the individual waves here, these tall, high amplitude waves, which are sometimes called delta waves, which is delta, the Greek letter that's assigned to this frequency, which is maybe 0.5 to 1 to a couple of cycles per second. These stages are known as non-REM sleep, and the slow wave, or delta sleep, is sometimes referred to as deep sleep, and is divided by how much delta there is. Nowadays, this is not scored by hand or by vision, but by computers. And a spectral analysis is performed so that if one is interested in, how much, what's the activity, what's the amount of delta, not only how often is it, but how high an amplitude is it, what's the total integrated amount, one can get that through computer measures. So different levels. We'll just remember this level, the delta or slow wave sleep. And then, as you know, it alternates with rapid eye movement sleep, sometimes called paradoxical or active sleep, where the EEG, except for a few changes, actually looks like the person is awake. That's why it was referred to as paradoxical sleep. And it's known historically as the state where people are dreaming. But in fact, without going further into it, you dream in all of these stages. So it's not just during rapid eye movement sleep. And then we can define with the polysomnogram, and you can do it right here, whether a person is awake in this deep, slow wave delta sleep or in rapid eye movement sleep, because we have the EEG, the eye movements, and the electromyogram, the muscle tone. So when you're awake, as you are now, I hope, the EEG has fast frequencies, low amplitude, fast. You're looking around at the screen shown here, and you have muscle tone shown by this thick line. You're sitting up, you're not limp. Here's deep, slow wave, delta stage 4 sleep. Here's the EEG with that high amplitude, slow waves that you can make out these individual waves. The eye movements are really not doing much. You're relaxed and the EMG has a lower amplitude. And here's the REM sleep. You see the EEG now starts to look like it did when you were awake. Here are these rapid eye movements that give this state its name. And in fact, you're paralyzed. So the EMG is flat. There may be a twitch. It's flat. There's no tone, right? You're immobile with no tone. And again, just to make the point, is this state is actively generated by the brain. So the lack of tone is an active inhibition of the motor neurons in the spinal cord. So those are the stages. There's a temporal landscape. There's an organization to how these stages cycle over the course of the night. This is called a hypnogram. On the x-axis is 8 hours, a sleep episode. And here are the states are at these levels. So here's wakefulness, stage 1, stage 2, stage 3, stage 4. As the subject begins to sleep, they're going back and forth between this light stage and wakefulness, tossing and turning up and down, and then proceeding through the stages until they reach the slow waves, here labeled stage 3 and stage 4. That's interrupted by REM, this dark black, and then again, a cycle, REM, a cycle, REM, and so forth. These cycles, the non-REM REM cycle, each of these is about 90 minutes on average. And you'll also see that all of the slow wave sleep is accomplished in the first, 3 hours, first third of the night. In general, for people, maybe 50% of the time they would spend in this light stage 1 and 2, a quarter in REM and a quarter in delta or deep, slow wave. Number three, sleep and waking are distinct physiological states. So here's sleep. Here's when you're awake. Here's asleep, awake, and asleep with the lights on, lights off. Here are the sleep stages. And during this time, there's other stuff happening. Temperature is dropping like so, right? You become cooler. Growth hormone is secreted. So if you're sleep deprived, the growth hormone is not being secreted. Cortisol, the stress hormone, is beginning to be secreted in anticipation of waking up to prepare you for the dawn. So sleep, the sleep state, is a composite of all sorts of physiological and metabolic changes. And the last, which is something that you know, is that sleep is fragile. If you were worried about a test in the morning, if you were stressed about something else, if you were ruminating, you may have a very poor night of sleep. So sleep is very fragile. In the lab, this is sometimes referred to as the first night effect. If somebody is getting a sleep study in the lab, and they go directly into the lab for their first night of sleep, it may look very abnormal. Here's the first night of this individual. This is one of these hypnograms. If we're looking, there's hardly any of stage 3 or stage 4 sleep, hardly anything there. The second night in the lab, once the person has gotten acquainted with it, now it's looking a little bit more normal, like we saw here. So sleep is fragile. All right. So what are the physiological systems that are sort of operating on sleep? And this is an old study, but I think it's really very useful to look at because it's kind of clear. There were Swedish soldiers, and they were sleep deprived for 3 days. And then on this top graph is shown their self-rated fatigue. Higher on the graph, they're more fatigued, and you can see the longer their sleep is prevented, they're feeling sleepy. Okay, the fatigue is rising. Here you can see it's rising. This is a performance measure here. This is the number of shots they can get off from their rifles over time. So it's a time test. And here, as they get more and more fatigued and sleepy, the number of shots they can fire drops. But when you look at this graph, you see that there are two things going on. One is the longer you're sleep deprived, the more tired you get. Okay, right? But the other thing is this, there's something here that's actually every 24 hours. And you may have had the experience that if you stay up all night, pull an all-nighter, in the morning, you may get a second wind and start to feel better. So there's something every 24 hours that's keeping track as well. And this is, as I'm sure you're aware, an internal timekeeping device, a so-called circadian clock. I won't go through sort of all the data that have led to this little cartoon, but the idea is that here what's being measured is how likely you are to be awake, right? So if it's going up, it's wakefulness, going down, it's sleep. And here is the beginning of the day at 9 in the morning, and you rapidly sort of become awake. You're awake during the day here. There's maybe a little bit of dip after lunch or in the afternoon. You feel pretty alert in the evening. And then here, when it's time to fall asleep, hopefully you fall asleep quickly, and you remain and stay asleep and then wake up. So this is this consolidated wake sleep that I hope all of you enjoy. And the idea is that this is the result of two regulatory processes, two physiological processes working in concert. One of them we call homeostatic, for reasons that I'll describe in a moment. But one of them is called homeostatic, and that relates to how long you've been awake. So that's this going up like so. And we can call that a sleep pressure or a sleep load. And here it's denoted, this is denoted as sort of a force pushing you down, trying to push you to sleep, pushing down your wake propensity, right? Opposing that is a timing signal, this circadian signal coming from the clock, which is giving an alerting signal, which is counterbalancing this to keep you awake. And it's the combination of these two forces, how long you've been awake versus the time of day, when those combine to keep you awake during the light phase, during the day. Here, something magical occurs, which if you took my course, we would talk more about. Something magical occurs, and this alerting signal is withdrawn and you fall asleep, relieving this sleep load. So you sleep. And on and on. So this raises the question of how many hours should you sleep? And this is on a site, this is the Vox site, there's a panel of sleep experts. And this is how many hours of sleep you need from this panel. And so you guys are somewhere here, maybe. So they say you need 7 to 9 hours. Me, I'm going to have to admit, they say, I need something like this. I need less, is what they say, hours of sleep. And you'll recognize that there's a problem with this. There's a real problem with this. And that's really going to depend a little bit on these curvatures, right? That's going to depend on some of these kinds of curves here. When you ask here in an experiment, people who are habitually short sleepers, so some of you may be, who routinely get less than 6 hours versus long sleepers who get habitually 9 hours. Here they are. Here was the measurements over a week. The short sleepers are filled in, and you can see that they go to sleep later and get up earlier than the long sleepers who are shown here. And then this experiment measured a lot of things, and we won't go through all of them except to say that if you ask, what have the short sleepers gotten rid of to be able to sleep for a short period of time, it's shown by the arrows. Well, their total sleep time is less. They have much less light sleep. They have much less REM sleep. What they have more of is slow wave sleep. They've increased the slow wave sleep. They've sacrificed all the REM sleep and the lighter stages to boost their slow wave sleep. And without sort of going through the evidence, I'll just say that the words are important. Slow wave sleep, which is classified as non-REM, is critically important and considered to be a marker of how much sleep you need, this sleep load or the sleep propensity. And without showing you the individual data, the slow wave activity is associated with the highest threshold to arousal. It's the deepest in terms of how hard it is to wake you up. I haven't shown this, but it's high at sleep onset. Well, we saw it was mostly in the first third of sleep. It's high at sleep onset and decreases over time with sleep. So you take care of it early. Its amount, slow wave activity, measured by spectral analysis, is proportional to the duration of prior wakefulness. And that's what we mean by homeostatic. So if the longer you're awake, that night, the more slow wave activity you'll have. If you take a nap during the day that has some slow wave activity, you'll have less slow wave activity in the night. So something in the brain is keeping track of how long you've been awake. Something is either accumulating or something is depleting, but something is keeping track. And the next opportunity when you sleep, it tries to recoup it. And the measure of that seems to be the slow wave sleep, the delta sleep. And it's conserved in short sleepers. But the question is, what is this sleep load? What is this sleep load? What are the physiological variables whose levels or activities are being defended by the homeostatic regulation of delta activity? And the point here also is that if there's work being done during sleep, which is what we're saying, presumably the benefit of that work would be how long you do it and how well you do it, or the quality or the deepness of how you do it, right? If you know cardiac physiology, the amount of blood pumped is related to heart rate, a timing measure, and stroke volume, how much with each pump. So presumably then, someone who is sleeping deeply, that is with really gearing toward their slow waves, could accomplish the same amount of sleep work in a shorter time than someone who is sleeping less deeply for a longer time. Both of them could get the same benefit. So the problem with this is only one measure, right? Now, it's true there's a lower measure. So even, if you really are a good slow wave sleeper, if you're sleeping less than 5 hours, the system can't recoup that. But given this, you might ask, and here's really a cool experiment. We'll have to move through it, but I just want to show you, these are the things that are happening now where certain kinds of stimulation are being tested in the lab to boost slow waves. And this shows the protocol of boosting the slow waves. Here, in this experiment is, for example, blown up. This is seconds. Here's a slow wave. Here's a slow wave. So there's a slow wave, that's occurred over a couple of seconds. In the red is with this kind of stimulation, and you can see they've boosted the amount of slow wave activity with this. And the result of this the next morning is there's better memory in the stimulated people, and the amount of memory retention shown here is related to how much increased slow wave sleep they were given. This is the control, where they actually do a stimulation at a different phase of the slow wave, which here doesn't really do much in blue, and it has no effect on memory. So you can think of all sorts of things that this will lead to probably in your lifetime. I just wanted to finish a bit with this part. So we talked a bit about this homeostatic. I'd like to talk about this circadian, this clock system. One of the ways that people have investigated this is by questionnaire. And of course, this leads to the issue of people who are early birds and night owls, right? This has to do with differences in the timing of the clock and this alerting signal, if you will, and its relationship to the outside world. So this questionnaire is a simple questionnaire asking when people go to bed, when they get ready to fall asleep, when they estimate they fall asleep, when they get up, and so forth, on weekdays, work days, and on weekends, free days. And this questionnaire was sent out, it's a number of years ago, This is an old tabulation with 300,000 individuals. Now it's higher. And what's graphed here is time, local time, from 11 p.m. to 11 a.m. And what's graphed is the hour, the time of day of the mid-sleep phase on the weekends. So here, for example, is someone who, say, went to bed at 1 a.m. and woke up at 9:30. The mid-sleep is 5 o'clock in the morning, a quarter after 5. So this is in hours, local time. And here's the distribution of these mid-sleep phases of these 300,000 people. And you can see it's a bell-shaped curve. So up here are the larks. So what does this mean? This means 11 a.m. for these few people up here, 11 p.m. for these few people here means, assuming 8 hours of sleep, roughly, it means they went to bed at 7 p.m., right? They went to bed at 7 p.m. and woke up at 3 in the morning, right? For an 8-hour sleep. Here are the people their mid-sleep phase is 11 in the morning, right? That means they went to bed at 7 in the morning. Those are extreme night owls. So there's this distribution. And what's responsible for this distribution? Well, I'll show something about age. We'll talk a little bit about light and also about genetics. So, there are over 300 genetic loci that may be involved in this distribution, which has been referred to, whether you're early or light, as your chronotype. That is like a phenotype, right? Phenotypes are blue eyes, red hair, so forth. Chronotype is your temporal type, early or late or in between. Here's sort of the chronotype of women and men as they age. And you guys are somewhere around here, I presume, sort of relatively late. This is the mid-sleep phase in time of day. And you can see it gets gradually later and later for both. Males generally later than females. There's this peak at around 20 or so, and then sort of starts to become earlier. Sort of at the end of adolescence, as it were. And then actually the difference between males and females is eliminated sort of once you get much older. Let's talk just a little bit about these late types. So if you were to graph sleep as this bar, so here's red bar, sleep. This is the timing of sleep. This is weeks here from going successive weeks, and here's local time. So here's a late type. This is a night owl, right? So they're going to sleep or getting into bed anyway. This is around 2, 4, 5 in the morning, around 5 in the morning, 4:30 in the morning. And they're up again at around 11 a.m. And here you see Monday, Tuesday, Wednesday, Thursday, Friday. Here's Saturday, Sunday is the weekend. They actually, sleep a little later. And here we go through that time. And this is fine. It's at a socially sort of inconvenient time for most people who would be having usual jobs. But, if you're a nighttime bartender, if you're a historian, if you're writing novels, if you're an artist, doesn't really matter, does it? You can sort of set your own hours. But for those of us who can't set our own hours, and is a late type, it looks more like this. And you'll see what happens during the weekend, and some of you may recognize this. And so here's a person who's a natural late type, is going to bed sort of at 2 a.m. or something like that. Here is Friday night, and they fall asleep when they feel tired, showing when their natural sort of falling asleep would be and their natural wake up. Here's Saturday night, same thing. Here's Sunday night, they get into bed early to try to fall asleep. Usually they have insomnia and can't because their natural falling asleep is here. And you see that actually they have to wake up maybe with an alarm clock at 7 a.m. And this goes on and on over the course of weeks. And there are two problems with this. This is not a disease. I mean, this is just a late clock. But it's a social problem because often for us, we have to go to class, we have to go to work early, and there are two issues going on. Let me back off. One of them is the person is sleep deprived, right? Because here we get a handle on sort of how the length of time of sleep that they actually need here. And for many of these days, it's less than that here. So they're getting sleep deprived for many days. Here, you know, he misses the alarm clock and sleeps through it. So there's some element of sleep deprivation. But there's also something which Till Ronenberg in Germany calls social jet lag. Because here they've delayed when they've gone to sleep. Here they've advanced when they've gone to sleep. That's like here on Friday night, if they've flown east several hours, right? Or flown west back several hours. And so every weekend, it's like they're in jet lag. So they have the combination of sleep deprivation and jet lag. And this has been associated with cognitive, psychiatric, metabolic problems. So the cause and effect relationship is not quite clear, but at least in our modern society, late types have a disadvantage. Finally, just a word about light. The clock, the circadian clock, as I'm sure you know, is synchronized by light. And this is just showing the amount of light that's required to have an effect on the clock is actually pretty low. So here, we'll call it maybe 50 to 100 lux. Here on this table, we see that we're in the area of family living room lights, office building, and the hallway. And now you'll recognize why you keep reading about sort of light devices in the evening, which the clock will see and register that actually that's when sunset is, and will cause insomnia and a whole delay of the clock to make it run later. The system for registering light in the clock is relatively recently described. This is a cut through of the retina. The light comes through here, passes through the layers. Here, you know, are the rods and cones for vision, for spatial vision. There's some neural circuitry that converts that to signals to ganglion cells here, which sends their axons, sends electrical activity to the brain. And relatively recently, and you may have heard of this, some of these ganglion cells have their own light-sensitive photoreceptor called melanopsin. That's different than melatonin, melanopsin. Those cells look different than other ganglion cells. And the melanopsin, the sensitivity of this opsin, is especially sensitive to blue light. So this is the explanation for why you hear about, oh, you shouldn't get blue light early in the evening with your devices or computers or TVs and so forth. And the reason for that is it will activate these general light will, but especially activate the melanopsin, which will inform the circadian clock that it should delay, actually cause sleep to come later, for example. And here's what's happening with light pollution, which you sort of know about all over. And so this is having an effect on our sleep and our circadian rhythms. I have a final clock, I see, because we had an introductory material that now it's 5:37. I think we're supposed to finish at 6. So I want to leave enough time for questions. So here are some basic ideas about sleep hygiene. You probably know them. These slides will become available for you. So I'll leave it to there for you to take a look at these afterwards. And instead, let's make it let's leave room for questions.
Perfect. Thank you for this very insightful lecture. I really learned a lot. Now I know what happens when I hit all-nighter. So thank you everyone. Thank you so much for the lecture. And then now we're gonna go ahead and open it for questions. Feel free to put them in the chat, or if you want to mute yourself and go ahead. So the first question, why do we usually fall asleep when we are sad or crying all day?
Let's see, where am I? I'm looking there. I'm looking to follow with you. I see wherever.
It's in the chat. So
Why
please,
can't I see. Okay.
yeah.
Well, then there's one, why can't deep sleep be achieved through the duration of the time sleeping? So that's Isaiah. So just quickly, if you deprive yourself of sleep, there is a rebound of the deep sleep. So you're right. You can generate more deep sleep. If you sleep longer, it would give more time for the deep sleep, but it chronically over time, it can't completely replenish. So maybe if you pull one all-nighter and then, sleep for a long time, you'll be in reasonable shape because you'll get the extra time sleep, which will give you more deep sleep. But if you're chronically sleep deprived or sleep restricted, at some point, it just can't make it. Why do we usually fall asleep when we are sad or cry all day? That's an interesting question. I don't know. From the questioner, I'm not sure that's true for me in particular, but it relates to the issue of, and the answer is we don't know. It relates to the issue of what is happening during the day to our brains, or we're doing to our brains, that is accruing this sleep load. What kinds of things? So does stress either deplete something, or does it build up something? Is an emotional sort of feeling build up something that has to be discharged during sleep? So it's a critical sort of question. What are the things that that are being relieved by the benefit of sleep? And the answer is we don't know. But learning and memory play a prominent role, as you probably know. So when you deprive yourself of sleep, there appear to be some metabolic functions, right, that are affected, immunological functions that are affected, so non-brain things, actually. Growth hormone is not being secreted. So a lot of things are, not happening. But presumably, things you've learned, things that are emotionally salient for you, whether it's love or fear or those things, perhaps those are being processed by sleep as well. There are a lot of questions. I don't know. Hiba, do you want to select some?
Sure, I could do that. Yeah.
And then we can backtrack,
Got it.
whichever ones you think.
Perfect. What is the effect of doing physical activity a few hours before sleeping? Is it positive or negative?
Generally speaking, physical activity, exercise, is, especially aerobic exercise, is positive. It sort of helps you with sleep, except if you do it too close to when you want to fall asleep, because exercise generally increases body temperature, and that's going to inhibit the sleep promoting systems. So one might want to leave several hours between eating as well as exercise and sleep.
Thank you. What is the reason for still feeling tired after having 8 to 9 hours of sleep? Could it be due to irregular sleep patterns?
Yes. Right. Yes. Because again, the irregular sleep patterns, either you're ignoring the clock, the circadian clock, which is, keeping a consolidated sleep, um, or the clock is not working right for a variety of different sort of reasons. So regularity of sleep patterns is important to enable you to have that first third of the night to really get the delta sleep, which I think is the most important. So regular sleep patterns are important, and that's going to be in the slide on regular sleep hygiene for sure.
Thank you. We have a question here. Why do some people, like even within family, take more time to fall asleep than others?
Um, well, because this so this gets to neurobiology again. The question is, we don't know, but based on here's an idea, um, um, and again, I don't know if anybody's at the University of Texas that could take my course, maybe. Um, we had said that there are systems to keep you awake and systems to put you asleep. And so you'd say one idea is that in order to go to sleep or fall asleep like a square wave, you would need the wake systems to turn off and the sleep systems to turn on. And there's evidence that they mutually inhibit each other. So you can imagine a situation where um, that that click doesn't work quite so perfectly, and the wake system may still be on a bit while the sleep system is trying to get on, vice versa, and so forth. And you can imagine how some of those things may relate to trouble getting to sleep. Another possibility would be, well, if somebody is a night owl, and just based on the genetics of their clock, um, they're going to be their chronotype, their timing of when they'd fall asleep would be later. And people don't have the same genetic makeup as everybody else in their family, obviously.
Perfect, thank you. Another question here in summary. How sleep deprivation leads to neurodegenerative diseases?
So it's always been known that people who have neurodegenerative disease, especially dementia, dementia or Alzheimer's disease, they do have sleep problems, fragmented sleep and so forth. And it was always thought that perhaps the neurodegeneration led to that, because the neurodegeneration might affect the wake and sleep neural systems, which makes perfect sense. But as the questioner sort of knows and has realized more recently, it appears that perhaps fragmented sleep may actually catalyze neurodegeneration and make it worse. Why that is not entirely clear. One popular idea is that during sleep, sleep serves, one of its function would be to rid the brain and the body of waste projects that might be harmful. And so, there's actually considerable research now on those kinds of ideas.
Perfect. Thank you for answering. How are toddlers balls of extreme energy after only sleeping for 3 hours, even though they require more sleep than that felt to be rested?
Right. So for toddler, I mean, generally, although the circadian clock is working actually in utero in fetuses, likely, because we see that in animals. The consolidated sleep-wake pattern that we know of takes some time to develop, presumably because, there's maturation of all the axons of the neural systems and so forth. Because in addition to, you'll also, and some of you may well have had this, other developmental issues that need to be formed are just making the composite sleep state. So some of you may have had sleepwalking or sleep talking, right? That's sleep that's not exactly right either, where all the pieces of the sleep state haven't come together again. So toddlers, of course, we make them take naps. Their sleep is not quite consolidated. So their sleep is occurring at these irregular times, and toddlers have much more slow wave sleep. You could probably answer that question yourself than the rest of us do now. So more of their sleep is taken up by REM and by delta. So again, the idea is when we talk about the amount of sleep, we have to keep in mind not only the time, the duration, but also, for lack of a better word, the quality. So you can get the same benefit of sleep, the same benefit of rest, if you like that word, by the type of sleep you do as well as how long you do it.
Perfect. Thank you. Since you've talked about deep sleep and light sleeps, is there a reason why some people have later sleep than others?
Well, there's a big genetic component. So, I mean, without going into some studies, for example, some of the geneticists have found families where the individuals are short sleepers, right? And so there's the genetic thing. And, the molecular biologists, in this particular case, it was autosomal dominant. So then they could go look for the genes and they can find particular genes that are associated with short sleepers who are, you guessed it, sort of really benefiting from mostly deep or slow wave sleep. And so that's why I showed very quickly just that wild experiment that you may think of is, well, could we just boost our slow waves? Could we put on a thing at night that would, generate slow waves? And shockingly, people are working on these ideas. And so I think something like this is likely in everybody's lifetime. Maybe not mine, but everybody's lifetime. And the key is, again, to rid ourselves of this misnomer of and you can tell your mothers or fathers that yes, and you can quote me and I'll call them if you want. You can tell them that it's true. If you don't sleep well, you're more likely to get sick with a cold. That's true. But it's not true necessarily that you need X amount of hours of sleep. Although it may sound silly, if you want to determine how much sleep you need in terms of time, and if you're getting enough, just ask yourself, do you feel tired during the day? If you don't feel tired or fall asleep, you're getting enough. So some of you are short sleepers, some of them are long sleepers. Presumably all of you are getting enough. You're all getting the benefit because of differences in this other measure of the deepness, if you will.
Perfect, thank you. Another question here we have in the chat, what strategies do you suggest to manage sleep schedule to support academic performance, especially in medical school?
Well, I think you sort of have to know whether you're a long or short sleeper, or whether you're an early or a late person. Let me recount that in the old days, so I'm talking about me, in the old days, when one took organic chemistry in college, it was an 8-hour lab, right, that began at 8 a.m. And so there was a systemic bias against late people. I'm sorry, there was a systemic bias against early people. Wait, hold. It's getting late now. There was a systemic bias against late people, right, who had trouble getting up early in the morning, right? Their first class was at 2 in the afternoon. And so what happened with them? Well, I can't deal with this, right? I'm going to take afternoon classes. And those people wouldn't be taking organic chemistry, or if they did, they wouldn't do very well. There was a systemic bias for entry into medical school for early people. We talk about systemic biases. There is a chronobiological bias. Crazy, huh? And so with that may have been, well, some people talk about personality types and so forth. So much of this is genetic. If you're a long sleeper or a short sleeper, if you're a late type or an early type, I would only say, there are many different, the beauty about medical school is that when you finish, you can still do almost anything. I would say to know yourself about, your sleep habit and how much you sort of need. So if you're a late type, maybe anesthesiology is not going to be the right thing. It doesn't mean you can't succeed in medicine or other health professions. So, I think the important thing is much of this is genetic. I would also sort of figure out at what time of day are you best for doing certain kinds of things. I haven't shown slides of that, but for example, for me, if I want to write, I really I do that in the morning. I can't do it in the evening. So I could be sitting in the evening trying to compose a sentence and I'm going nowhere. And the next morning, it just comes. And so people have different times when they're best at proofreading, when they're best at exercising, when they're best at creating, when they're best at writing, all these different things. If you know that, then you can budget your time and arrange your time at different times of day. My daughter, who's an extreme late type, did her best creative work at 3 a.m. And, being her circadian rhythm sleep dad, I was able to tell her how to get her schedule so it was more normal, quote unquote. And we succeeded, and she said she didn't like it because she wasn't creative in composing the music like she could before. So most of it is knowing about yourself. People who get by with 5 hours of sleep and who are motivated and talented can do a lot better than the rest of us. That's all I can tell you, because unless they're wasting their time when they're awake. But you have other good qualities that they may not have. So I guess that's the best I could say with that. But an important one is what are the times of day that are best for you to do what you do? And you may know these already, and you can test them out.
Perfect. Thank you. I think you touched a lot of answer on these questions.
I mean,
Okay, yeah.
I can stay after 6 if people want. That's fine.
Perfect. Thank you.
The other thing is that we should say before anybody leaves, on the slides is my email address. I recall, I think.
Mhm.
Um,
We
uh,
can double check.
email me.
Perfect. Thank you.
I mean, I'm working for you. We can set up a Zoom, whatever you like. Yeah.
Oh, perfect for having that. It's very awesome of you. Thank you.
Yeah.
We do have a question here. Is there a distinguish between a microsleep and a nap?
Generally speaking, microsleep refers to these kind of zoning out unawareness, which might be seconds, where you might still be doing automatic behavior, like walking or reading, and then realizing you 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 didn't realize you read the last paragraph or you didn't follow it. So those would be seconds. Whereas a nap generally, right, is, I don't know, even a quick nap is several minutes. Yeah.
Perfect. Thank you. They have another question. What stage of sleep is important for cognitive benefits?
For cognitive benefits,
Hmm.
well, it depends on the kind of cognition. So even when you look at memory, and this gets sort of into a detail, but the kind of memory that we call declarative memory that depends on the hippocampus um, is really sensitive to slow wave sleep, delta sleep, whereas procedural memories like how to ride a bike, something like that, that has motor, is less so and might actually depend more on REM sleep. So, memory is there are many different types of memories when you get down to it. Hippocampal dependent, not hippocampal dependent, the type of hippocampal dependent memory it is, whether it's a memory just for memorizing dates and schoolwork or for what you had for breakfast. All those sort of depend on different neural circuits. But generally, some of the, um, short to long-term memory that people think of that depends on the hippocampus, the delta sleep, that seems to be very important.
Thank you. We have a question here. Where was it? What would be likely effective alternating between a night of about 5 hours of sleep and a night of about 9 hours of sleep? So like alternating between the number of hours of sleep each night.
Um, I don't know. They could try it. Um, uh, if they were doing it during the night, and they sort of alternated like that with the same sort of, with the timing the same, like they either went to bed on those nights at the same time or woke up at the same time, each of those, they could try it. Yeah, I'm not sure, actually. Not sure. And see how they feel. Because that would be a schedule. That's a schedule. Maybe do 6 and 9, because 5 is really pretty tight, if they want to try an experiment.
Okay, try and listen now.
But I think, but if they wanted to try that, I would anchor it. In other words, anchor when they wake up or anchor when they go to sleep and keep that the same in the experiment and not vary the 5 hours within the 9 hour window.
Got it.
Yeah. And
Okay,
don't
we
tell
have
anybody I told them they could do it. Yeah.
okay, we have another question here. How long do people take to usually get to sleep?
Well, generally I mean, when everybody here was a kid, or if anybody has babies, you see that often it's almost like a square wave. And you just conk, bang, you conk out. And that certainly happens if you're sleep deprived, where you're lying down on the sofa and you just drop out. Generally for a good sort of sleeper, one would, and where this mutual inhibitory circuit of the wake system versus sleep system is working, and they're opposing each other and inhibiting each other, it should be minutes to fall asleep, right? As opposed to an hour or something like that. It should be on the order of minutes.
Right.
Now, somebody who's a late type, a naturally late type, who's told by their parents, get in bed, at 9 p.m., they'll stay awake they could stay awake for hours. And staying awake for hours and not being able to get to sleep, that's one possibility. There are many other possibilities as well that don't relate to a clock issue, and have to do with depression or
Stress.
anxiety and other things like that. Yeah.
We have another question here. Would a power nap during the daytime compensate for sleeping fewer hours than the healthy recommended range?
So people talk about, there are all these kinds of alternate sleeping schedules that are out on the internet, Uberman or something of these, where they're giving short bursts across. Those I can't recommend. Actually, and some of those have been studied, and some of those, for example, would interfere with growth hormone secretion or other metabolic things. Now, the question about a power nap, though, where you would take an afternoon nap every day, where you would get some slow waves. So let's say you took a nap at 3 p.m. There is at least one paper I know of that argues that actually that improves sort of memory retention. So I think there's more research on that's due, sort of a strategically placed power nap, which might, if you did it in the afternoon, not too close to nighttime sleep, and where it had, a fair amount of slow wave activity, there might be something to it. So for example, let's say you had an exam at 4 p.m. and you studied for it, in the early afternoon, and then took a power nap before that exam, that would be something that I could get into, right? Yeah. Certainly the thing you study right before sleep is likely to be the best encoded.
Perfect, thank you.
So not these uber goofy sort of sleep schedules, but a strategically placed power nap in the afternoon before your exam. Remembering that, it takes time to wake up, this sleep inertia, so don't make it too tight.
It's not that I can sleep stressed, so I don't think I can do that. But thank you so much for that. I think that was all for we have one more question. A question more about your experience. What was the process like to become a professor at your medical school? And was the clinical practice required alongside prior to teaching?
So maybe that the person could elaborate on that question of exactly what they were after.
I think what they mean, like, what's the process of becoming or want to be a professor to teach at a medical school? Like, what's the required stuff to have, like, as a degree wise, stuff like that?
Well, yeah, that's a longer kind of conversation, and it depends a little bit on the specialty the kind of track you're on, whether that person is thinking they want to be a tenured professor or not. And so there are all sorts of different opportunities and different kind of tracks of professor. So it sort of depends. So for example, at most all medical schools, there may be people who are actually in clinical practice, in a private practice, and who have an affiliation with a medical school where they're given a title, and it would include the word professor with maybe some other words associated with it, where they're teaching. So medical students or residents might rotate into their clinical practice and see patients with them, right? And that person would typically have an MD. They wouldn't be doing research, right? On the opposite end of the spectrum might be somebody who is running a lab, is having federal or other grants, is doing research as a professor, is not seeing patients, maybe never saw patients. And that's sort of the opposite. And then there's all sort of in between. So it would sort of depend a little bit on sort of what the person was interested in doing academically.
Got it. Perfect. I hope this answered your question. If there's not any more.
Did we answer everything?
Yep, I think we do. If there's anything, you guys let us know. But overall, thank
Yeah, before you hang up, let me just make sure in my slides that, and they have these slides as the PDF, is that it?
we can upload them, but they usually get whatever we have in the recording. If you want me, I can also
Oh,
post
in the
the email
recording.
in the
Well,
chat.
I had sent you the PDF, right?
Yeah.
Yeah, so let me close this. Right, so on the first slide is my email.
Perfect. And you
So,
guys can see it in the recording.
and if they if they put in the subject line
from
pre-shadowing,
PL shadowing, you guys will able to.
or from pre-shadowing advice or something.
Perfect. Thank you so much. So thank you everybody for joining here us today, and thank you so much, Doctor, for being here. I've personally learned a lot. Again, just a breakdown, you guys will be able to get your shadowing hours just after taking a very easy 10-question quiz. It'll be right on the website right now. You can take whenever you want, right now or later. It's forever lifetime on there. Along, it will have the recording, but the recording will take around 24 hours to be uploaded, just so we're able to download and then have it. You'll be able to have it on the website, and it will be also on our YouTube channel. You'll also be able to see all of our older live sessions that we had. You can also take the quizzes for these ones as well and download your certificates. You are able to take the quizzes multiple times, but if you ever have any questions or any problems doing that, you can always email us at info@prehealthshadowing.com, and we'll be happy to help you as well. And yeah, make sure to do the donations if you're able to. The links are in the chat. Every donations help us keep this program free and accessible for everybody here. And it's our pleasure to have all of you. So if you have no more questions, you can hop off or you can stay to the end to do so.